Well, thank you so much for coming. I know a lot of you had late nights parties, and I know I did. And I thank you so much for coming to the first session on time. I'm going to be talking about AAA mobile games with Unreal Engine. My name is Arvind Neelakantan. I am the solutions architect for Unreal Engine, mostly focusing on mobile optimization and performance. Now, mobile is very, very important for Unreal Engine. So today, the agenda is as follows. There's a lot to pack. So I'll just kind of keep going, and we'll have maybe some time at the end, if we do have time at the end for questions. Otherwise, I'll be hanging out in the Dev Hub also. But we'll begin with the introduction. We'll talk about Android-specific workflows. And when I mean Android, a lot of these also kind of translate to iOS, but I'm going to stick to Android because there's just so much to pack that it doesn't make sense to kind of pack both iOS and Android into one talk. So I'll talk about the initial Android setup, the build size reduction, performance optimization, and how do you debug Android projects. And then I'll also talk about the future, which is a question I get asked all the time about, hey, Nanite and Lumen on mobile. We'll also bring that up. So if you're making Android games, which is like AAA quality using Unreal Engine, you're not alone. How many of you are already making Android-based or just mobile games using Unreal Engine over here? That's a lot. Cool. So I think you might know some stuff, but I'm sure you'll kind of pick up some new things that you might not know about. And again, give you examples of content or games that's already been made using Unreal Engine on mobile. We have like Tower of Fantasy, we have the Oregon Trail, we have Ni no Kuni, and of course Fortnite itself. And I'm from India and from Asia, so from my neck of the woods, there's a lot of games like Raji, Final Fantasy, and Blue Protocol, which are all games that's made with Unreal Engine on mobile. So about myself, I've been making games for about 15 plus years. I'm a full stack game developer. Typically, I'm going around South Asia, Middle East, and Africa, providing technical direction to studios who want to use Unreal Engine, especially on the mobile devices. I also lead some instructor-led initiatives, especially on the infrastructure part, which I product own. So a lot of cloud-based stuff is also things I deal with. So let's dive right into the talk. For this talk, I'll be using this example content, which is Crop Out. It's a cross-platform game that's available in the marketplace for free, and it also works on mobile. So on the right-hand side, you can see that game is running on a portrait mode, and it also works on landscape mode. But that's the game that I'll be using for this talk to kind of walk you through some examples and scenarios. Now, when you talk about the initial setup on Android, it's documented. You can go to this QR code. It's essentially like basic things like going to the project settings, making sure that your Android platform is all supported. You set up your OBB file, and you set up your target SDK. And then you also kind of scroll down, make sure that your Google Play things are all set up correctly. So your Google Play Services platform is enabled. And of course, the big thing with Android is setting up your Android SDK and NDK correctly, which, if you follow the document exactly as it is, you'll get it in a couple of tries. First things that you do when you enable Android is that you want to preview your game before you launch your game right inside the editor on the preview platform of your choice. So you can see that there is a nice little Android button that shows up on top, but that doesn't show up automatically. You need to enable it by going under Settings and go under Preview Platform. And then under the Preview Platform, you select which platform that you want to preview your Android build in. And of course, that also includes iOS devices also. So this gives you a good idea about just getting into the game, and without having to launch it, you could just see the game as you would on the preview platform. The other lesser-known feature is that you could also preview on device right from the editor. Now, you'll notice that something strange is happening. Like I have Google Pixel, Samsung S8, S9, and they're running different processors. And you'll notice that the shaders aren't really showing up, even though they were showing up in my editor. And these are kind of things that you can catch while you're previewing right in the editor for the mobile preview. And so to enable this mobile preview, just go under Editor Settings. There is a experimental section. Under experimental, if you scroll all the way down, you just enable the Vulkan mobile preview, also enable the mobile PIE with preview devices, and that's it. And once you have that turned on, you can now go to the standalone game target mobile device. You have iOS and Android, and there's a list of devices over there. Now, I do want to preface that a lot of these devices are fairly old, and we are, in fact, I'll talk about it when we talk about the future. We are now supporting the emulators provided directly by Android without having to go through this kind of a process, but this works now. Now, let's talk about the big elephant in the room, which is build size optimization. That's typically the question I get asked all the time, which is like, hey, my build sizes are huge. Like, what do I do about it? Well, let me show you how you can reduce your build size. Now, let's talk about the baseline, right? If I have an empty shipping build, like I create a new project and I just ship it, I just build it. Now, you'll notice that the baseline that I'm working with is my APK size is about 75.1 megabytes, and the storage on my phone comes to about 196 megabytes. Now, forgive this commas if someone is reading and they're like, hey, why is the commas all messed up? That's how they roll in India. But that's 75.1 megabytes is what you have as your baseline APK and OBB file. Then how do you deal with it? So if you look at a fresh crop out build, now when you have a development build instead of a shipping build, it gets fairly bloaty because it has all the symbols and all the libraries that is required for development. And if I make a fresh crop out build with development settings, then I get to about 218 megabytes. Now keep an eye on this little number over here, because we'll kind of show you the journey of how we are reducing the build size from there. And of course, your storage on your mobile is about 662 megabytes. Now, you don't want development build, obviously, because when you're shipping, you're going to be having a shipping build. And this is a mistake that I also see some Android developers make, because they want to support a wide variety of Android devices, which is 100% of all Android devices, the target Android devices. They often set up the texture compression to be multi, which includes the ASTC, DXT, and ETC2 compression. And that will mean, essentially, you're having 3 textures for the same one texture that you have in your game, which will also bloat your build size. And even if I select shipping and I select multi on my Android settings, my build size, although it has reduced from 218 to 169 megabytes, you can still go about reducing it even further. And because you don't want ASTC, DXT, and ETC2 all turned on at the same time, if you're smart, with Google Pad, which allows you to have APKs deployed based on the specific Android configuration of your user, you can just say, just make an APK which is just an ASTC build and not all the other texture compressions. And so that also significantly reduces your size. So from 169 megabytes for a shipping build, we went down to 135 megabytes for crop out. And of course, your storage also went down significantly. Now, the next point is a little contentious. Now, you have forward and deferred rendering now supported on mobile. Now, this is a decision that you need to make entirely up to your creative department about your lighting setup and whatnot. But I just want to highlight that this exists. If you choose, let's say, forward rendering, so you go under project settings, go under rendering, you have the mobile shading option of forward or deferred. If your game is using forward shading, your game size does get reduced by about 3 megabytes. But it does exist. I don't want to highlight. And again, this entirely depends on your lighting setup, on the look and feel of your game. But if you're using forward shading, you kind of shave off 3 megabytes on your overall APK. And your storage also goes down by about 5 megabytes. Next big thing that you want to do when you want to reduce your build size is removing unwanted plugins. Now, again, the vanilla empty project has about 147 plugins enabled. Many of them are like editor plugins, so you don't really care about it. But if you know that there are certain plugins that you really aren't using, you could scroll down the list and remove plugins that you don't care about. So in my case, from 147 plugins, I went down to 106 plugins. And in fact, I could go even more aggressive on the plugins. And so with that reduced, by the way, do not uncheck Oodle, because that actually helps reduce your build size quite significantly. Make sure Oodle is turned on. But if you remove unwanted plugins and you could go even more aggressive, on crop out, I wasn't too aggressive, but I did shave off another 2 megabytes. From 133 megabytes, I went down to 131 megabytes, and my storage also reduced on my phone. All right, this is cool. Let's go even further. Your OBB file or your APK file is just an archive file. So you can, in fact, unzip it using like 7-zip or your unarchiving tool. And you can unzip it and kind of take a look at the pack files to see exactly what is built inside the OBB or the APK file. Now, you'll notice that there's 3 files in there. There's a pack file and a couple of other files. Now, you could look into what is contributing to your OBB or APK file size by looking into it. And the way to look at it is to use a utility that's under your engine binary Windows 64, which is called unrealpack.exe. If I open up the command line, I can just run unrealpack.exe. I can specify the path of my extracted file. So in this case, it's a ucas file. So I'm just going to go under my pack folder. It's not the pack file. It's the ucas file. And I just add -extract. And then I specify which folder I want these ucas files to be extracted. So I'm just going to extract it under a folder called extract folder. Just hit enter. After a few seconds, it should be extracted. Now, I can now go into my extract folder, jump into my crop out sample project, and this will now lay out exactly what is contributing to my APK and OBB file. So, for example, I could go under meshes, and you'll notice that the water plane is about 2 megabytes. Do I even need it? Do I not want it? You can kind of make a decision about it. But more interestingly, you'll also notice that there is also the engine folder under the extract folder, which also contains some content that I'm not even using probably. Like for example, if I go under engine materials, and I have substrate in there, but in my game I'm probably not even using substrate, so why do I care about it? So you can now exclude content from the engine folder also, which will further reduce your build size. And to do that, you have to create an INI file under the config folder called default packfile rules.ini. It's just a text document. Just call it default packfile rules.ini. Change the extension to an INI file. And once that's done, I don't want to change it. Just open that up in your favorite text editor, in my case, I use Visual Code. And I'm going to paste in some values in there, and I'll talk about what these values mean in just a bit. Now, if you look at the values, it says exclude default. And in there, I'm setting the targets, saying in which targets do I want to exclude all of these files? And I'm going to say, yes, I do want to exclude from the pack file. I do want to override the chunk manifest file, which is set to true. And if you're making a cross-platform game, you can also set up the platforms in which these files needs to be excluded. So in my case, it's iOS and Android. And under that, in all these files, you can specify, hey, I don't want all of these files. I'm not using it. But be careful about it, because some files might be really useful and required by the engine. But if there are some files let's say, the crane rig mount, which I'm not even using, you could just remove that. And so going pretty much line by line, file by file, you can remove some of the engine content that you know that you're not going to need in your project. And if I do that, of course, I need to make a build once I make the default files, once I make the INI file. And now you'll notice my build size went down from 133 megabytes to 121 megabytes, or 128 megabytes, sorry, which is, again, a considerable reduction. I know we're chipping away, right? Just chipping away. But all of this matters to the end user. And my storage also went down on my device to 273 megabytes. And it doesn't end here. You could go even further. If you go under project settings, under packaging, you can set only the specific maps that is required for you to be packaged. That means that other levels like test levels that you have, or sample levels or developer levels that you have will not get packaged, which will also further reduce your build size. With crop out, it was already done, so I didn't have to do it, but that's another thing that you need to keep in mind. While we are in the project settings, there's also a prerequisites installer, which is typically used on, like, say, Steam or like on PC builds, but that's not really required for Android, so you could also remove that. And if you remove that, then we went down from, we kind of shaved off one megabyte. So 128 megabytes, we went down to 127 megabytes, and also reduced on the storage size. And it doesn't end here either. But let's look at our journey, right? We started off with 218 megabytes on a shipping build to 127 megabytes by just doing all of these things, and that's significant. That's almost 100 megabytes of data that we, or download that we have saved for our users. And our storage size, or the install size on the device, also went down from 319 megabytes to 271 megabytes. It doesn't have to stop here. We could go even further. And that's through chunking. Now, chunking was traditionally used for, like, DLCs, right? Like, you separate out your assets into different chunks so that when you want to push an update, it's only the chunked assets that you're going to be putting in. And that's a very valuable use for mobile, and especially when you want to reduce your build size. So to enable chunking, you need to just go under your project settings, under packaging. Just ensure that you have the generate pack files, or use pack file and use iOS store, which is what generates the ucas and utalk files. And then you also ensure that you have generate chunks enabled. Once you have that enabled, it's now time to separate out assets into logical pieces so that you can only have the base install of your game, and the other assets are being downloaded after the base install is installed on your device. So now I need to just go into my asset manager. Under asset manager, there is the primary assets to scan option under asset manager. There's already map and primary asset label, which is there by default. I just add an additional one. In my case, I decided that I want to separate out the environment meshes, which is something I don't need at the basic installation of the game. So I'm just going to create a primary asset of a type, which is asset base type is going to be object. There's also other object types that you can select, or base class that you can select. You do need to be a little wary about the blueprint classes, because if you enable that, the blueprint classes which extend the asset base class will be the only assets that will be bundled with your pack file, which means that anything that's not a blueprint will not get bundled, so you need to be a little wary of it. And then I'm going to directories, selecting the directory that I want to separate into a pack file. And I'm going to add rules. Just set the priority of my directory, let's say 100, and chunk ID should be anything that's greater than 0. I'm going to set it as 1, and that's it. Well, one last thing is at the bottom, you have this option. If I scroll down, you have this option which says, should manager determine type and name? Just enable that so that the asset manager kind of picks up the assets by type and name automatically. You don't have to manually specify it. So I usually just turn it on. Once that's turned on, just let's make a build again, and that's it. Once I make a build, I can go under Tools, Audit, and Asset Audit. And if I go onto the window and I just refresh Add Chunks, you'll now notice that there's chunk 1, which is now a completely separated out file or pack file in my game. And I can also unarchive my OBB file and kind of take a look at it, and you'll now notice that this has a pack 0 and a pack chunk 1. Now you might be thinking like, hey, but that's still part of the OBB file, so how does this really reduce my build size, right? Well, you can exclude these chunks to be from the base OBB file, and that's by going under config, under the default engine INI file. You can set rules in there where you can just say, when I'm making the build, exclude all the chunk files that I'm specifying. So I just need to specify Android runtime settings. Under OBB filters, I can just say like anything that has the name pack chunk 1, excluded. I don't want it to be part of the build. And now if I make a build and look into my OBB file, the chunk 1 is gone, and I only have chunk 0. And that also means that my build size has also reduced from what was 127 megabytes to 122 megabytes. Right there, you can see it right right, the green thing isn't working. Okay, but that's how you can reduce it. But the chunk one didn't go anywhere. It's just under your staged builds. And that's where now that you have your chunk one and how many ever chunks that you want, you can then host those chunk files on your server, let's say on a AWS S3 bucket. And you can then download those chunk files after the user has then installed the base game itself. So even if you have like a 4 gigabyte or 100 gigabytes game, I don't know why you would have that, but but it shouldn't matter. Like your base install, even Android only allows you to have like a 2 gig OBB file, but that's not a constraint for you anymore. And you can kind of learn more about how to host chunk files on a server by just scanning this QR code or going into that link. So now you can go even further. If I go under chunks, under the size map, I can also look at what are all the assets within the chunk which is contributing to my size. So in this case, let's say there's a bridge 03, which is like 9.5 megabytes. What is causing that? I can also open up the reference viewer and see exactly what level or what other blueprints are exactly referencing this asset. And if it's an asset that's not referenced by anything or is being referenced by something I don't really care about, I can even go further and delete them from my project, which will further bring down the size. So to talk about the journey, we went down from 218 to 127 megabytes and 120 megabytes, and even further if you're going to chunk your assets cleverly. So your base size could be very, very lean if you want to. And of course, your install size doesn't reduce at all. It's exactly the same, but except that your download size does reduce. You can go even further if you want to. Under the shader permutation reduction, which is under rendering, because a lot of times what's contributing to your build size is also just like shadow maps and just the amount of instructions that your shaders are going to be giving. So you can go under project settings, and even depending on the lighting settings and the look of your project, you could go under the shader permutation reduction or the mobile shader permutation reduction. And let's say you only have like dynamic lights in your game. You can then remove that combined static and CSM shadowing, for example, and then go in and remove that, which will also reduce your build size quite significantly. So that's all about the build size reduction. Next, let's go to performance optimization. Now, the first things that typically when you're talking about performance optimization is how do I optimize my mesh? So in this case, let's talk about that. So this mesh is Nanite enabled. And Nanite in many, many Android devices are not supported. And note the many, many, because I'll talk about that later. And because Nanite isn't supported on mobile, it's typically going to fall back to your LODs, which is your LOD0. And your LOD0 might also be quite heavy. So when you're making a build, when you're optimizing your mesh, you have the option to create mobile overrides. So if I go under the mesh and under the LOD settings, I have already generated about 3 LODs. In my minimum LOD setting, there is a plus button. I can then add an override saying, for mobile alone, don't use LOD0. Instead, use, say, LOD2. So when the game is being packed or packaged, it's going to ignore the LOD0 and 1. It's only going to package LOD2, which also, by the way, reduces your build size, but also helps you with the mesh optimization part. Now, you might be wondering, like, hey, I have like thousands of meshes in my game. Do I have to go under each mesh one at a time and then add these mobile overrides? That's going to be a lot of work. Well, not really. If you have done that for one mesh, you can go under level of detail by just right-clicking and copying the LOD settings and select all of your static meshes or all of your meshes and go under level of detail, and you can paste the same LOD settings from that one mesh that you have done into all other meshes. So it's like a one-time operation. So once you do that, everything else has now the mobile override set to LOD2 automatically. Next up is texture optimization. Now let's take a look at this texture. This is a 2K texture, and maybe I don't care about a 2K texture, or this is a bridge that is not even close to my user's camera, so I don't really care about it. So what you need to do in order to optimize texture, especially when it comes to cross-platform games that you're creating, you need to make sure that you set texture groups in your textures as a practice. It's a very good practice. Now, why would you want to set up texture groups? If all of your textures has separate groups, you can then go under the device profile, which is under Tools, Platforms, Device Profiles. And under Device Profiles, you have all the platforms that's supported by Unreal Engine. And you can specify overrides based on the platform that you're going to be deploying your game to. So I have Android. By the way, if I select Android, all other Android devices under it kind of has these options will permeate to them too. So with Android, the parent device selected, I can open that up. And under that, you have the texture LOD settings. And there is all the texture group settings that I had. So I can say, if anything is set to world, I don't want a 2K texture. I want to make it into a 1K texture. So during package time, or when the game is being packaged, it's going to ignore the 2K texture and instead make it a 1K texture. And I can go under any other, I can set up different kind of groups. So I can go under, say, character. Maybe my character is the hero of my game. So I want it to have a bigger resolution of the texture. So for that, it could be 2K. But say vehicles or background elements or buildings or even the ground, I can have like lower texture sizes, all done during package time. And while we are in the device profiles, I also want to talk about console variables. You can also set up CVARs or console variables and create overrides specific to the platform. So in my case, I'm on Android. I can go under rendering, and I can say, like, you know what, don't render the grass. Or, you know what, I don't want to render fog. I can also go under the physics and just turn off physics. Maybe it's like in Crop Out game, there is a little hat that the minions are wearing, and it kind of bobs up and down. I don't care about it on mobile. It just adds to my overhead. So I can just remove physics from my, I can do that specific to the platform, which is Android, by going to the console variables. Then let's talk about shaders. So here's an example shader. So typically when you create a shader, the first things you want to do is go under platform stats and look at the number of shader instructions for that particular shader. Now by default, there's only DirectX and DirectX Mobile. But you can also add Android by going under settings right there. And you can then add the Android, whichever platform that you're targeting your shader on, so you understand how many instructions are there. Now you'll notice that there is a warning that shows up saying like, hey, for mobile, for Android at least, I need a offline shader compiler to be enabled before I can give you the full information. And that's because you need to specify where your Mali offline compiler exists. So under Material Editor, under the project's editor settings, there is a Mali offline compiler, and that's empty by default. So then you need to go under the ARM developer website, download the version of Mali that works for your low-end spec, and then go back to your editor preferences. Just point to the exe file, saying, hey, here is my exe file. And now that warning is gone, and now this will give you the right kind of the number of shader instructions specific for Android. Another feature on shaders has been around for a long time, and that's called feature level switch. That's a node that I recommend you all use quite a bit, especially when you're making a cross-platform game. Now, in this particular example, we have a gradient, a sediment gradient, that is quite expensive on mobile. So instead of using the sediment gradient over there, I'm just going to create just like a white texture, like a white color, a vector 3. So in there, I can say like, hey, if I'm going to be packaging this shader for an ES2 build versus, let's say, an SM6 build, then use the same shader, but it's going to switch. It's gonna switch the instructions for the shader based on the platform that you're going to be packaging in. So for cross-platform games, it's a terrific use, so that you don't have to have two different shaders. You can have the same shader, but you can have use the feature level switch, kind of switch the shaders based on where you're deploying this to. All right, so let's talk about debugging Android projects. Now, how many of you have seen this? You open up the game, it crashes. No one? Really? You open up the game again, crashes, right? And this is something you see all the time. Now, instinctively, for Android developers, you're going to then open up your logcat file, and then you're like going to look through your logs and say, hey, what's causing this crash? Well, the epic recommended way of figuring this out is actually using what's called the Android Game Development Extension for Visual Studio. This is a fantastic plugin, which is provided by Google for Visual Studio. And you just need to go to the Android developer website and just download it and install it, and it'll automatically get installed for your Visual Studio, let's say 2022 or 2019, whichever ones that you're using. Once you have this, you just need to regenerate your Visual Studio project files for your projects. Just right-click, generate Visual Studio project files, make a build. Let's say I'm just going to Android, because Visual Studio obviously cannot make a APK file, so you need to make an APK file from Android. And now go into Visual Studio, set up your configurations to be like debug for the target platform, which is Android, and set the target project to be the game that you're working on, which in my case is Cropper Sample Project. Now, I do have my Android device plugged into my PC, so that's why I'm able to then launch that game directly on my device by just clicking on this play button. Now, it takes a little bit of time, like about a minute or so. It'll just copy all the debug symbols into my Android device. And if you're running Android 14, you might face this error, which is a assert error, which will say, I can't connect. And so it's to fix that. And that's a bug which Google is fixing right now. But you just need to go under debug into your project, debugging options, and add a command, which is the LLDB post-attach commands, and you paste that. If you're wondering what that is, this is what it is. Someone wants to take a picture. That's what it is. So you just copy-paste this into your LLDB option, and this only happens on Android 14, not on any other OSs. So once that's done, this is what your experience would look like. So you're connecting your Android device. It's going to install that APK. And on my mobile device, it's going to say, I'm waiting for the debugger. It's going to attach the process. Just wait. In a little bit of time, it's going to now launch the game. It's going to launch. Wait for it. There, bang, crash. And now it's able to catch the crash directly in Visual Studio, which is awesome. And you can also create checkpoints. By the way, let's see what's causing the crash. It's a CPP file called crash actor, well, appropriately named. Someone wrote abort. I wonder who. And I can then remove that abort line. And that's it. And you can also create breakpoints from directly in Visual Studio. You don't have to open up your Android development kit, Android Studio. You can just do it all through Visual Studio, which is amazing. The other cool thing is you don't have to keep making the APK file from Unreal Engine in order to debug code. If you add this into your default engine.ini, this line, which says don't bundle libraries in APK, and set that to true, that means any code changes that you're going to be making, you can just kind of directly push it without having to cook and create your entire APK cooking process, which could take time depending on the size of your project. Just code changes can get iterative quite fast. All right, now let's peek into the future of what Android and Unreal Engine has for mobile. Let's begin with developer workflows. Now, one of the things that artists, especially and technical artists, would appreciate is the ability to iterate on content, especially on materials and VFX, directly inside the Unreal editor and preview the visual that they would be able to see. And we have been taking that into note. And since 5.3, we have added Vulkan mobile support for preview. We have also improved support for Android and iOS and whatnot. With 5.4, the visual fidelity that you're able to get with the preview platforms has also increased. And there's also the device profile preview for various devices from iPhone 13 versus iPhone 8 and whatnot. And we also now support the emulators provided directly by Google if you want to, instead of doing that inside the editor. For the future, we are going to be supporting multiple simultaneous previews. So you can have a lot of previews so that you can kind of compare and contrast your shaders or VFX. There's improvements to the fidelity that you're able to get in these preview platforms. There's going to be more rendering features that will be supported on all of these preview devices. In terms of iteration, we do need to reduce the time that's needed to build your game and get it running on your device. So we don't want to keep cooking and cooking and cooking all the time. I'm sure you've all gone through that if you made it. And especially for large productions or if you're working remotely, this could be quite cumbersome. And we're taking that into account. With 5.3, we added multiple process cook, which means that your cooking time is reduced. We also added virtual assets and, of course, improved support to the Android game development extension that I was just talking about earlier. With 5.4, if anyone was at Ari's talk yesterday, he talked a lot about this, which is we now support Unreal Build Accelerator, the Unreal Zen storage for local and shared DDC. There is Unreal Cloud DDC, and then there's also improvement in terms of Android code only iteration times, like the ones I just showed you earlier. For future, we are going to continue working on rapid on-device iteration of content changes for large-scale games, and also enable incremental cooking. So it's only going to change or cook assets that you have changed rather than having to cook the entire project over and over again. You must have noticed that, especially on the build size optimization, I was going around clicking a lot of buttons like, hey, check this up, don't check it, uncheck this, and whatnot. And that's, if you don't take a note of it, that's a lot of checking and unchecking that you got to do. And we have, of course, taken that into account. So we are improving the usability of out-of-the-box experience, especially for people working on mobile games. And that's like the user experience that you have in the editor. So we have async loading in editor and plain editor. There is discoverability of mobile-specific properties and features, so that you don't have to go under project settings and scroll all the way. It's just got to be like a mobile-specific part of project settings. There's also going to be a refactor on the content browser and details panel. And we're going to be adding more templates and project samples specific to mobile, like crop out sample, for example, so that you could kind of play around with it, dissect the game to kind of see how Unreal or Epic Games has set it up. There's going to be also a bit better default settings for mobile platforms so that you can just say default for mobile and everything is turned on or off by automatically. For platform support on Android, we have updated Unreal Engine for all the new SDK versions and all the support for Android-specific features. With 5.3 rather, we have support for Android Studio Flamingo or Giraffe, with Android 33 SDK supported along with the NDK 25.1 that number, and support for Android file server plugin. With 5.4, I already talked about the experimental emulator support, and there's also support for x86-64 binaries. For future, the experimental emulator support will become production-ready emulator support, and we'll continue adding SDK updates based on the requirements by Google. Let's get into rendering. So we do have a dedicated mobile renderer that supports both forward and deferred. And of course, deferred works on, let's say, higher-end mobile devices, which has the style-based GPU architectures, but lower-end devices are probably going to stick with forward rendering. With 5.3, we added compute-based landscape vertex culling. There's also a fog volume that we added. There's also the global distance field generation for only forward shading. We also added support for runtime virtual texturing, especially if you're interested in like landscape and open worlds. And of course, improved CSM quality so that your shadows look a lot better. With 5.4, there is a new mobile GPU scene, which will automatically batch draw calls for you, which will then essentially reduce the number of batching that you need to do or number of draw calls you need to do. There's also improvements on dynamic lights. So if you have a party game inside in mobile where there's like, disco party going on, you can add a lot of dynamic lights. And there's also runtime PSO caching so that your shaders are cached before your users or players launch into the game. So it's done through caching. For future work, we are going to support more rendering features and continuing to work on performance so that you're able to really squeeze performance out of Unreal Engine just out of the box. Now the big question on everyone's mind, hey, Nanite and Lumen, what's up with that? So on most recent mobile devices, we do have the fully featured desktop renderer, which will bring a lot of the UE5 rendering capabilities to mobile. But I do want to preface this with saying this is on the highest and the highest of mobile devices at this point of time. So with 5.3, we added experimental support for SM5. With 5.4, we have experimental ray-traced Lumen GI supported. And for future, we are working on Nanite on mobile. And we're also working to make sure that the rendering quality that you're able to get on mobile is truly AAA quality as what you'd see on a desktop device. So in conclusion, some advice. When you're making a mobile game, test early, test often, and test on your low-spec device throughout your development process. And when you're beginning production, make sure that you're identifying your lighting setup so that you know whether you're going to be using dynamic lighting, whether you're going to be using deferred shading. You need to figure that out at the beginning of your game. Then identify the min-spec device. What is the min-spec target device that you're going to be deploying your game to so that you can keep testing on that? And as creative directors or technical directors, you need to then create a budget for your artists so that they know what are the limitations within which they need to work. You don't want artists to create a 8K texture and then you can and then going back to them and asking them to reduce it, or they're creating like a 1 billion polygon mesh, whatnot. You can tell them what these are the constraints and this is the budget that you need to work with, which usually enables a smoother production process. Then finally, keep profiling. There is a lot of these. People talk about profiling a lot, so I didn't really bring that up in my talk. But the typical tools like StatFPS or Trace or Profile GPU, these are all tools that's available out of the box inside Unreal Engine. And other tools supported by, say, Xcode or Android or even Snapdragon or Qualcomm, they also work in tandem with the Android or with the Unreal projects that you're going to be packaging on mobile. So use all of those tools and keep profiling your game so that you're able to optimize it and catch things that are breaking your game early in the production process. Then you have our product roadmap. Now, it's a public product roadmap, and we are often putting out all the features that we are going to be developing on Android, on mobile. So you can kind of check it out. You can scan that QR code or go to that link at the bottom. And you can also vote over there. So if you feel that there is a certain feature that you really like, that you think is important for you, go to the product roadmap and vote for it. And if there's a lot of people voting for a particular feature, then that'll be reprioritized so that that'll be available for you in the next version of Unreal Engine earlier than what you would expect. So that's about it. That's my talk. It's all about Android, but I hope you got a good idea of how to reduce your build size, how you can do performance optimization for your meshes, textures, shaders, and how you can how you can debug your Android projects, and taking a look into the future of what we are working with Unreal Engine on mobile, because mobile for Unreal Engine is very, very important, and we'll continue working on it. So thank you so much. Thank you. Thank you. Thank you. Thank you.